A packet arrives at a router. The router checks its routing table and drops it. No matching route. The network is broken, and you're the one who has to fix it. That's what happens when routing fails. Today, we'll make sure you never leave a router without a path. Every host on a network has to decide where to send its packets. If the destination is in the same network, the host sends the packet directly, no router needed. But if the destination is in a different network, the host has no choice. It must send the packet to its default gateway. That's the router that connects to other networks. The host addresses the frame to the gateway's MAC address, and the router takes over from there. How does the host know who its default gateway is? Usually, DHCP tells it. On Windows, run ipconfig, and you'll see the default gateway listed alongside your IP address and subnet mask. Now let's look at what happens inside the router. When a router receives a frame addressed to its own MAC address, it strips the frame and examines the packet inside. If the destination IP is the router's own address, it processes the packet locally. But if the destination IP belongs to someone else, the router performs a routing table lookup. The routing table is the router's database of known destinations. Think of it as a set of instructions. Send packets for network X out this interface, or to next hop Y. Without any configuration, the routing table is empty. But the moment you configure an IP address on an interface and bring it up, the router automatically adds two routes, a connected route and a local route. A connected route is a route to the entire network on that interface. If you configure 192.168.1.1 on interface G0/0 with a /24 mask, the router adds a connected route to 192.168.1.0/24. Any packet destined for an address in that network will be forwarded directly out of G0/0. Connected routes are marked with a C in the routing table. A local route is a route to the exact IP address of the interface itself, always with a /32 mask. If a packet is destined for the router's own address, the local route tells the router to receive the packet instead of forwarding it. Local routes are marked with an L. Here's the critical concept. When multiple routes match a packet's destination, the router selects the most specific one, the route with the longest prefix length. A /32 route is more specific than a /24 route, but this is called the longest prefix match rule. And it means a local route to 192.168.1.1/-32 will always be chosen over a connected route to 192.168.1.0/24 when the packet is destined for 192.168.1.1. If no route matches the destination IP, the router drops the packet. Routers never flood packets, like switches flood frames. They forward, receive locally, or drop. Now, connected and local routes only cover networks directly attached to the router. To reach remote networks, the router needs more routes. There are two ways to get them: dynamic routing protocols, which we'll cover later, and static routing, where you manually configure each route. Let's say you have 3 routers in a chain: R1, R2, and R3. PC1 is connected to R1, and PC3 is connected to R3. R1 doesn't know about PC3's network. It will drop the packet. You need to configure a static route on R1 that tells it to reach 192.168.3.0/-24. Send the packet to R2. The command is IP route followed by the destination network. by sites like Ccna Ch9, the subnet mask, and either the next hop IP address, the exit interface, or both. If you specify only the next hop IP address, you get what's called a recursive static route. The router has to perform two lookups. First, to find the next hop IP, and second, to find which interface that next hop is connected to. If you specify only the exit interface, you get a directly connected static route. The router treats the remote network as if it's directly connected. The problem? It tries to ARP for the destination host's MAC address, which fails because the host is on a different network. The router relies on proxy ARP on the next router to reply on its behalf. This works, but it's fragile and wastes memory. Avoid this type in real networks. If you specify both the exit interface and the next hop IP address, you get a fully specified static route. The router knows exactly where to send the packet. No extra lookups, no proxy ARP dependency. This is the most reliable approach. Finally, the default route, 0.0.0.0/0. This matches every possible IP address and is used as a catch-all. When a router has a default route pointing to an ISP, any traffic that doesn't match a more specific route gets sent toward the internet. Without a default route, the routing table shows gateway of last resort is not set. On the exam, you'll be tested on route types: network routes versus host routes, recursive versus directly connected versus fully specified, and on configuring static routes in lab simulations. Know the IP group command syntax, understand longest prefix match, and remember, a router without a route will drop the packet.